Static equilibrium tension force. There is a whole field of problems in engineering and physics called statics. It has to do with cases where no acceleration occurs and objects remain at rest. Anytime we construct bridges, buildings, or houses, we want them to remain stationary, which is only possible if there is no acceleration or no net force. There are two types of motion that we need to consider, and in both cases, motion is to be prevented. What are those two cases? The two types of static equilibrium relate to linear, which is called translational, and rotational acceleration. Linear acceleration would be when the object or components of the object is moving in a straight line, and rotational acceleration when it pivots about a point and rotates. Neither works very well on a building or a bridge. So in order to prevent acceleration for the first case, the net force is equal to 0, and in the second case, the net torque is equal to 0. We'll talk about torque later. Only the linear acceleration will be covered in this section. Rotational equilibrium is covered in the rotational motion chapter. Earlier we studied problems where there is a box hanging from a rope. Force of tension was up, mg is down. In the cases where there was no acceleration, force of tension was equal to mg. So there's also a case where an applied force acted on one object but not the other one, and a tension force was between the two objects. Again, these forces acted in the same dimension. So let's try a few problems on this again. It was covered earlier in this chapter, but it's a good time to review.